Page 266, we have a summary of all the polynomial factoring techniques. The first few we've already gone over, so I'm going to do those pretty quick. Factoring out the GCF, that's just looking for what they have in common. In this specific example, you could take a 5x squared out of everything and then you write what's left in the parentheses. Quadratic trinomials, you factor ax squared plus bx plus c, so let's find the factors of the product a, c, and sum b. That's the x box, so this is done using the x box. Perfect square trinomials are the shortcuts we learned, but you are welcome to use the x box. The x box would work on both of these. Differences of squares is also a shortcut, but you can use the x box for it as well, as long as they are using perfect squares. Over here you can see they used 15, so you can use the difference of squares and just take the square root of whatever number they give you. Now, factoring by grouping and sum or differences of cubes, these two are brand new. So factoring by grouping you may have seen before, but notice we have 4 things. We can't take anything out of all 3, and it's starting with a cubed. We don't have any fancy method for this yet. So factoring by grouping means you take 2 terms that have something in common and take that piece out, look at the other 2 terms, see if they have anything in common, and take that piece out. Many times when you do this, the leftovers inside the parentheses will match. So you can then factor those leftovers out and you write whatever was left in a new set of parentheses. So over here we have x cubed plus 2x squared minus 3x minus 6. These don't have anything in common altogether, but x cubed and 2x squared both have an x squared I can take out. If I take x squared out of x cubed, I get x. If I take x squared out of 2x squared, I get 2. And then looking at negative 3x and negative 6, those both have a negative 3 we can take out. So we can say plus negative 3, and if you take negative 3 out of negative 3x, you get x. If you take negative 3 out of negative 6, you get 2. And then notice we have an x plus 2 here, we have an x plus 2 here, with something being multiplied to each of them. That means we can factor the x plus 2 out. So here's our x plus 2, and you write whatever's left over. So over here we had x squared, over here we have negative 3. So really that's just kind of factoring the GCF out twice. Sum or differences of cubes are also shortcuts, but kind of the only method we use. So there's no like x box for the cube that we're going to use. So you really have to reference to sum or differences of cubes. So if you see something being cubed plus something else that's cubed, you're going to need to use this sum or differences of cubes formula. Same thing if you see something being cubed minus something else being cubed. So I used to always get confused about sum or differences of cubes because it's something you have to memorize, and I was never good at memorizing stuff. So a friend of mine taught me SOAP. Literally the last 2 years in my grad program they told this to me so that I could remember it easier. SOAP is used for sum or differences of cubes. So you look at whether you have a plus or a minus on the inside, and then the first sign will be the same. The second side will be the opposite, and the third sign is always positive. So if we have a plus, same as plus, opposite is minus, and always positive is plus. Down here we have a minus, so same as minus, opposite is plus, and then we have always positive. Now that doesn't help you remember the a and b, and then a squared minus ab plus b squared, but it does help you with part of it. So over here we have 8x cubed plus 1 and 8x cubed minus 1. Notice 8 is a perfect square, so we can rewrite this as 2x cubed plus 1 cubed. And then our a would be 2x, our b would be 1. And you just plug it into this formula here. So this is the one time where I'm giving you some formulas and I'm going to tell you to use them. And there's no way that we're going to like use an x box or show all the work instead for this, but I will still go over why it works. So I'm not just going to say here's a formula, use it. On page 267 we have why it works. So factoring a cubed plus b cubed equals a plus b times a squared minus ab plus b squared comes from the fact that a cubed plus b cubed, notice we still have a cubed, we still have b cubed. I've got a squared b being added, and then I'm going to go ahead and subtract a squared b. So really I added 0. I'm going to do that again. We've got minus ab squared plus ab squared. Now if we factor by grouping, I can take an a squared out of these first 2 terms. That leaves me with a squared times a plus b. We have an a left over, we have a b left over. And then over here in these middle terms, I can take out an a and a b. There's an ab here, there's an ab here. So if I take out minus ab, that leaves me with just an a and just a b, so a plus b, because I also took out the negative. And then over here we have ab squared and b cubed. Those both have a b squared that I can take out. If I take the b squared out here, I'm left with a. Here I'm left with b. Notice now every single term has a plus b, so I can factor the a plus b out of everything. That's right here. And then we can write whatever's left over inside the parentheses. So if I take out all the a plus b's, I have a squared minus ab plus b squared. So it gives you little steps over here. And then for a cubed minus b cubed, we get the same thing, just a minus b, a squared plus ab plus b squared. You would follow the exact same steps, just change the signs. Or you can factor a cubed minus b cubed as the sum of cubes a cubed plus negative b cubed. And then you could just plug it in up here. So now on example 2, we have two parts. Part A says, what are the real or imaginary solutions of the polynomial equation x to the fourth minus 3x squared equals 4? So I'm going to take the x to the fourth minus 3x squared equals 4, and we want to move that 4 over. Now notice this almost looks like a quadratic equation. We have x to the fourth minus 3x squared minus 4, except usually this is squared, this is just x, and this is still a constant. So we can actually use a substitution where we let a equal x squared. So if I plug in a equals x squared, well, x to the fourth is just x squared times x squared. So note, x to the fourth is equal to x squared times x squared, but we said let x squared be a, so that's a times a, or a squared. So we can rewrite this equation as a squared minus 3a minus 4 equals 0. Now we just have a quadratic equation, and we can solve this in whichever method we want. I'm going to go ahead and use the quadratic formula. Now normally we say x equals, but we're using a right now, so I'm going to say a equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know there's an a in here, and then we also used a, so a may not have been the best use of a variable. A is what the book used. They didn't show the steps for factoring, so I'm writing out the quadratic formula. They just skipped to it being factored. So if you can see how it's going to factor really fast, you can go ahead and write that out and skip this step, but I'm going to write everything out. So if we plug everything in, we get a equals negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 4 all over 2 times 1. And we can go ahead and simplify this. The first round of simplifying gives us 3 plus or minus the square root of 9 plus 16 over 2. This becomes a equals 3 plus or minus the square root of 25 over 2, and 25 happens to be a perfect square, so we get a equals 3 plus or minus 5 over 2. This is two separate answers, so let's write them out. We have 3 plus 5 over 2, which is 8 over 2, or 4. And then we have 3 minus 5 over 2, which is negative 2 over 2, or negative 1. Now, these are not our final answers. Remember, we're trying to solve for x. We substituted a for x squared. So this doesn't really give us the answer of 4 and negative 1. This says x squared equals 4 and x squared equals negative 1. So we need to plug that back in. So when we plug x squared back in, we get x squared equals 4. And then we can take the square root of both sides. So x squared square rooted becomes x, and then plus or minus the square root of 4. And then the square root of 4 is 2, so we have x equals plus or minus 2. And then over here, when we plug in x squared for negative 1, take the square root of both sides, we get plus or minus the square root of negative 1. Remember that I is equal to the square root of negative 1, so we have x equals plus or minus I. So this actually gave us 4 answers. We have 2 real solutions and 2 imaginary solutions. So our 2 real solutions are x equals negative 2 and 2, and our 2 imaginary solutions are x equals negative I and I. Now the book does a check by using the graphing calculator, so if you just plug the original function in, you'll get this graph, and it shows you the 2 real zeros at 2 and negative 2, so those are the 2 real solutions. And then over here it says it also shows 3 turning points. This means that there are imaginary roots which do not appear on the graph. So those are the 3 turning points we're looking at here. For part B, we have what are the real or imaginary solutions of the polynomial equation x cubed equals 1. So if we have x cubed equals 1, we want to move the 1 over to the other side. We can subtract 1 from both sides, and this gives us x cubed minus 1 equals 0. This is a difference of cubes because we have x cubed, which is a cube, and negative 1, where 1 is 1 cubed. So we can say that a is going to be x and b is going to be 1. So using a equals x and b equals 1, we can plug this into our formula up here, and that gives us x minus 1 times x squared, and then 1 times x is just x, plus 1. So back to our original equation, we had x cubed minus 1, or 1 cubed equals 0. We can rewrite that as x minus 1 times x squared plus x plus 1 equals 0. And then using the zero product property, we can separate those two. When we set each part equal to 0, we have x minus 1 equals 0. You can add 1 to both sides. This gives us our first answer of x equals 1. On the other side, we have x squared plus x plus 1 equals 0. That's the same as 1x squared plus 1x plus 1 equals 0. This helps you identify a, b, and c are all 1. So we're just going to plug 1 into every space up here that's got an a, b, or c. This gives us x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. If we simplify this, we get 1 minus 4 inside the square root, and then the bottom becomes 2. Simplifying even further, we get 1 minus 4 is negative 3. Now, square root of negative 3, we need to take the negative out. So to take the negative out of the radical, you need to write an I. This becomes negative 1 plus or minus I radical 3 over 2. So our final answers for part B are x equals 1, x equals negative 1/2 plus I radical 3 over 2, and negative 1/2 minus I radical 3 over 2. Both part A and part B have all the slides with the work shown, including the check for part A. So you can refer back to these if you'd like. And then I would like you to try to find the real or imaginary solutions of 8x cubed equals 1. So move that 1 over and then take a look at that table that has all the different ways to factor.